You're preparing for a game show where you play the following game. You're faced with 4 doors. Behind one door is cash money, and behind the other 3 doors is a steaming pile of broccoli. If you pick the door with money, you get the option to play again at the risk of losing the money you've collected thus far. If you keep winning, you can play a maximum of 3 rounds before the game show host kicks you off his show. You have some strategy ideas you'd like to evaluate before you go on the show. So you hired an unpaid intern to scour through historic recordings of the show and log data on where prizes were located and the value of each prize. Your intern gets back to you with the following matrices. Prize doors, a 5x3 array where element ij gives the door hiding the prize in the jth round of the ith game, and prizes, a 5x3 array where element ij gives the prize amount in round j of the ith game. Build a 5x3x4 matrix where ijk represents the prize behind door k of round j of game I. Okay, here's the solution that I came up with. Let's go ahead and break it down. So the first thing I do is initialize an array called answer. So answer is a 5x3x4 array of zeros, where this corresponds to the fact that we have 5 games. Each game has 3 rounds, and each round has 4 doors. And these values are like the cash prizes behind each door. So we want to update the values that we know have cash prizes behind them. And that's going to be given by the prize doors array and the prizes array. So let's start by sort of looking at the prize doors array. Now, these doors are actually indices. And so, for example, prize door 1, this means that in the first game, in the first round, the prize was behind door number 1. And that's going to correspond to the first game, first round, door number 1 is going to be this guy. So we'll want to update this value with the cash prize 100. So if we think about these doors where the cash prizes were hidden, well, this is game 0, round 0. This one represents game 0, round 1, game 0, round 2, game 1, round 0, game 1, round 1, game 1, round 2, and so on. So we can build corresponding 5x3 index arrays for the game indices and the round indices. So let's go ahead and do that. So if we say game indexes, and we'll set this as, again, we want to make it a 5x3 array. So 1, 2, 3, 4, 5. And so the games we're interested in are going to be 0, 0, 0, then 1, 1, 1, 2, 2, 2, 3, 3, 3, and 4, 4, 4. And then we can do nearly the same thing for the round indices. So the rounds in this case are going to be 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, and 0, 1, 2. And again, I'm building these indices so that they sort of line up with the prize doors array that we already have. So now what we can do is we can say, well, answer square brackets, and we'll pass in our 3 index arrays. So game indexes, round indexes, and prize doors. And we set that equal to the corresponding prizes. So this actually gives us the solution. We're just not satisfied because it's hard-coded. So how do we make these arrays a little bit more dynamic? And we can do that with broadcasting if we set up the appropriate row or matrix and row indices. So np.arrange 5 square brackets colon comma none is going to give us this array here. So it's a 5 by 1 array. And then np.arrange 3 square brackets none comma colon is going to give us this 1 by 3 array. So these two arrays, when we pipe that into the square brackets here, they're actually going to broadcast, and this column is going to get copied 3 times, and this row is going to get copied 5 times. So they're going to be identical to the game indexes and round index arrays that we set up earlier. But this way it's a little bit more dynamic and easier. So putting it all together gives us my original solution.